Hi guys and girls. Today we're going to be looking at the how do we differentiate between the chemical and physical properties of elements on the periodic table. So we're going to move into the periodic table and looking at those elements there in this unit. So in order for us to do that, let's just review a little bit. We've already talked about physical and chemical changes in matter. You know that a physical change is reversible. It doesn't chemically change the element that you're looking at, but a chemical change means that you get a new substance. So we want to really look at how that happens and look at the properties of elements on the periodic table. So again, matter is any substance which has mass and occupies space. That's also known as volume. And all physical objects are composed of matter in the form of atoms. And again, mass is the amount of matter an object is made of. So, characteristic properties in science. A characteristic property of matter is a distinctive quality or attribute that can be used to identify a substance. For example, if I said to you that something is small, it is round, it is red, it smells good, it tastes good, many of you would probably guess that I'm referring to an apple. So when you look at these characteristic properties, they can be used to identify a substance. For example, where do we use metal? Why? Metal has distinctive properties that allow it to be used for certain things in a way that other objects couldn't be used as well. For example, I wouldn't use plastic pots. Why? The fact that I can't use plastic to cook with, that makes it a property of plastic too. It helps me identify it from other substances. So metals have a property, and one of those properties is that you can cook with it. And plastic has a property, and you can't cook with it, and that's the property of a property of plastic. Physical properties of matter are any characteristics of matter that can be observed without changing the identity of the material. Again, a key word there is observing. You can observe the color, the shape, the smell, taste, mass, volume, solubility, and solubility, by the way, is dissolvability. What state of matter it is, what's its freezing point, what's its melting point, etc., and density, the mass divided by the volume. These are all physical properties of items that you can observe. For example, if you look around most classrooms, a physical property of most classrooms are that they are painted white or beigey white. And so that is a physical property of a classroom. It's something that you can observe. You also have substances that are acids and bases, and we're going to talk more about this in the later of the year, but those acids and bases have physical properties that help us identify them. For example, you can tell if it's a base because it feels slippery, it tastes bitter, has a pH level above 7. You can tell if it's an acid because it tastes sour. It'll burn you, and it has a pH below 7. So even though you don't have to know those properties of acids and bases now, you should get an understanding that they do have physical properties that you observe that can help you identify them. Chemical properties of matter. Chemical properties are characteristics of matter that allow it to change to a different type of matter. In other words, you get a new substance. These properties have characteristics that cannot be observed without altering the identity of the substance. So, in other words, a chemical bond has taken place. You can only observe chemical properties while the reaction is occurring. For example, look at number 1. Is it combustible? Will it react with air and an accelerant to create heat? This is something that you don't actually know is a chemical property of a substance until it actually happens. And just in trying to think of something that may not combust, typically humans don't combust. That is not a chemical property that human beings have. I'm not saying that it's never happened, but it is not a typical chemical property. And if it did happen, you would only be able to know, hey, a human being can combust because they're actually combusting and you can see it at that time. So whether or not something is combustible is a chemical property. Look at number 2. Is it flammable? Will it burn? That's a chemical property. There are many items or pieces of matter out there that have this chemical property. Trees, wood, homes, all of these things will burn. A third chemical property, will it rust? In other words, is it reactive? That is a key word that you look for when you're looking for a chemical property. If it reacts with another substance and changes into a new substance, then it is reactive, and that is a chemical property. When I ask you, will it rust, basically what I mean is if you set it outside, it probably has to be metal. Will it react with oxygen in the air and moisture in the air to create rust? And that, if it does, then say for example a bicycle, a chemical property of a bicycle is that it will rust. Number 4, did a color change take place? Going back to the chemical and physical changes that we talked about earlier, I'm asking you, did a color change take place during a reaction? Not, oh, hey, the apple is red, but hey, the leaves turned red before they fell to the ground. Number 5, did it create a gas or bubbles during the reaction? If so, then a chemical property of that substance is that it will create a gas. Number 6, is there a temperature change up or down during a reaction? So if you have a reaction where the temperature increases or decreases, then a chemical property of that substance is that it will have a temperature change as it reacts. Did it create a precipitate? A precipitate is a solid that typically forms, say, for example, if you have a Alka-Seltzer and you drop it in water and that Alka-Seltzer dissolves, but then it leaves a white ring around the edge of the glass. That white ring is called a precipitate. So if it is a substance that creates a precipitate as it reacts, then it is a chemical property of that substance. So again, you also have chemical properties of acids and bases. For example, strong acids will react and corrode metals. Strong acids and bases are equally dangerous, and an acid and a base will combine to form a salt. So those are some chemical properties of acids and bases that let you know whether or not a substance is an acid or a base. So now let's go back to the physical properties of metals. Now hopefully we've been in class and we've been able to color code our periodic table and talk about our periodic table, but if not, we'll just, it'd be great if you could pull out a copy of the periodic table right now. If you did so, you would see that groups 1 through 13, except for boron, are all metals. So groups 1 through 13, except for the element boron in group 13, are all metals. Now let's talk about some physical properties that they all have that lets you know it's a metal. Most metal are solids at room temperature. If you look at a metal, you can see that it's a solid. Most metals are located on the left side of the periodic table. They're very dense, they're shiny, they're ductile, which means they can be drawn into thin wires. They are malleable, which means they can be hammered into thin sheets like aluminum. All metals are good conductors of heat, and They are good conductors of electricity. So those are some properties that all metals have in common. They're solids, they conduct heat, they're good conductors of electricity. The boiling points of metal, that is a physical property. What point does it have to be heated up to get it to start to melt? You know that a metal has to be heated to a very high temperature before it is going to start to melt. So all metals have boiling points in the hundreds and thousands. And you can tell if an element is a metal on a chart just by looking at its boiling point. If it has a high boiling point, then it's a metal. So let's look at nonmetals. Nonmetals are on a very small portion of the periodic table, typically in group boron, and then groups 14, 15, 16, and 17 are all nonmetals. Well, how do you know they're nonmetals? What are their physical properties? What do they have in common? They are typically solids at room temperatures. They're not very shiny. They're not malleable. You can't hammer them into sheets. They're not ductile. You can't pull them into wire. Nonmetals typically don't conduct heat very well or electricity, and that's why we don't use them as conductors. We typically use them to insulate items. They have boiling points in the low hundreds or even in the negatives. It just doesn't take very much to boil a nonmetal. Properties of metalloids. Metalloids are located right between the metals and the non-metals on the periodic table. That's why they're typically called semi-metals. They only partially conduct electricity, and they're always used in computer chips and as semiconductors. So in electronics, you can control how much electricity and heat goes through them. So to sum it all up, physical properties describe the element. It is what you observe. And if you make a physical change, it can be reversed. Chemical properties of elements are the characteristics that allow the element to change into a new substance. And if you make a chemical change or if it reacts, it cannot be reversed. Again, if you look at the periodic table, all of the metals have certain physical properties, all of the nonmetals have certain physical properties, and all of the metalloids have physical properties. And that's what helps us identify what type of element it is, whether it's a metal, a nonmetal, or a metalloid.